Hello and welcome back to another episode of our Tech Talk Show. In the RISC-V Summit in San Jose, we were blown away by the impressive traction that the RISC-V ecosystem has gained in the recent years. The embedded world has shipped billions of RISC-V cores, and the demands of this innovative and flexible process continue to grow. We are also excited. Before we begin, we are also excited to have today Mr. Sajad Khan, CEO of Silicon Valley Global PH Inc. Welcome, sir. It's an honor to have you once again. And without further ado, let's dive into today's discussion and latest development in the RISC-V community.
Okay, so we talk about, again, we talk today about the CPU, which is a very, very early stage. The CPU was created by, Intel, and Intel created the 8086 and 286, 386, 486 machine Intel. Then they go to Pentium, and they go, right now we call it different cores, but before there was no cores. It was just different, like normal things like a calculator or a small, but the computer was too big in the past. So right now there are a lot of processor companies, CPU design companies, and go to fabrication as well. So Intel is one of them, and there is still leading on the process with the desktop market, with data centers, and with the mobile. Of course, we go for ARM chips, and mainly on the mobile market. But Intel desktop and the hardware, the data centers, they're already still the giant there. Lately, the AMD, they really gain momentum with they really fill the gap between Intel and but of course Intel take a very big step lately last when the new CEO came in to the picture, and they are putting up their own fab, they're putting up the design lab, they're upgrading their system to come up all the way to the 3 nanometer chips and all those things. So today we are going to discuss about the different things. Intel is not RISC. Intel is basically, we call it CISC. So that is very complex system. So because of the complex systems, they call it reduced instruction set. So why they do it? The instruction set was too many. Then they come up with, they call it the reduced instruction set. So this RISC technologies basically came for small devices in the past, which is the main goal was to power the calculator, and later on it powers all the cell phone right now. But it grows its own way. So the RISC and the CISC, which is Intel, are based 86, and we call it x86 machines, which are AMD and Intel is basically powering. So it has their own proprietary systems, and also of course for the AMD they have their own proprietary system for the RISC. So what this US based schools, the university teacher, they come up with this new idea to put up this open source the RISC. So they call it RISC-V. Okay, so these are the RISC-V CPUs. These are the open source, because when you're talking about a proprietary logic board or proprietary design, you have to pay millions of dollars. For example, you want to be a designer, and you want ARM chips you want to modify or develop. You have to pay ARM initially license fee. For example, $5 million immediately you have to spend for your license fee. So that is quite bit of expense. So they come up with this open source, the RISC-V CPUs, and these RISC-V CPUs in the past it took them years to develop. Of course, right now they have more than, I think, 3,000 members on their development community. I mean, they are actively develop these RISC-V CPUs. Even Intel, they invested $1 billion to the RISC-V CPUs development. So all the people, they come up together, because there will be a lot of devices in the future. Even your all the things in the house will be connected, and everything will be smart, and it will be having its own brain, which is the CPU. So we need to have those those functionalities. So that's why they come up with this open source so that people can design on a cheaper ways the CPUs or the architecture in the future. They can design any kind of architecture. IoT is coming, artificial intelligence is coming, a lot of other things are coming up. So I will not talk about more anymore. I'll ask Atif to talk about what is really the RISC-V CPUs.
RISC-V, or long-term reduced instruction set computing version 5, is an open-source instruction set architecture, or in short, it's called ISA, that defines the hardware for our computer's central processing unit. It was developed to be a simple, modular, and extensible ISA that can be used in a wide range of devices, from small microcontrollers to large servers.
Okay, so basically that is so it has very vast use. So we'll go a little bit later. So it was initially designed basically for a small task because itself is a reduced instruction.
Simple.
So it's basically it was designed that way. But when Apple, like iPhone, they created this chipset, which is what is the name of
The M chipset.
the M chipset for the laptop. That they have A series for the mobile. But when you talk about the reduced instruction set computing, I do not see anything reduced because I see 16 billion transactions in there. So what I mean is, of course, but the advantage of the RISC-V technology, it is not power hungry, unlike the Intel or AMD machines. They are very power hungry. So basically what right now, I think in the whole world it is having a percent of the electricity is being used for server and technological things. So meaning we're losing a lot of electricity or lot of consuming powers in the computer and data centers and others. So of course this RISC-V is like it takes only very low power, but what they're trying to do is they're right now making the efficiency levels higher while keeping the performance level higher, while keeping the power consumption very low. So example, if the RISC-V or RISC CPUs are coming up more, and Intel and AMD will not change their ways and their consumption will be used on the power. It will be not maybe very far that this RISC-V CPUs will be very popular in the future. So basically, it's already taking its momentum right now, and we in the past we were thinking about the little devices will be powered by this, but right now there are CPU design company. We will talk about it a little bit later that they are already taking step to put these CPUs to the desktop, to the server market as well, and this will take at least 1/5 of the electricity power will be reduced. So that's basically how it will be done. So I will ask Isha, how does the RISC-V CPUs work?
As Sir Sazat said, a CPU is a brain of a computer that executes instructions and performance tasks. It consists of two main components, the control unit and the arithmetic logic unit. The control unit fetches instructions from memory and decodes them into a form that the ALU can understand. The ALU then performs the calculations or operations specified by the instructions. The RISC-V CPUs are based on reduction instruction set computing, or RISC philosophy, which aims to reduce the number of instructions needed to perform a task. This simplifies the design of the CPU, making it smaller and more efficient.
Okay, so basically that's basically why they call it RISC. They come up with the instruction set that is going to take maybe the similar performance of the CISC they will perform, and it's gonna take only very small instructions set will be needed to perform the similar task. Basically, that's basically why that they call it RISC. It is reduced instruction set. So for that, basically, there are a lot of companies, as I mentioned, that if I'm not mistaken, there are more than 3,000 companies in the whole world, government, the different designing companies, and and some other companies, they are joining forces in this open source RISC-V technology that is coming up, because everybody want to create their chipset, make their product cheaper, this basically, right? For example, Apple right now are having the ARM. It is also RISC-V based, but the problem is they are paying to ARM.
Yeah.
Okay, right now even Apple itself, there are technologies, there are parts that inside the is powering the laptop and the mobile is already have the RISC-V controller. Like example, they have the controller, they use the RISC-V because they don't have to pay for the licensing fee anymore. But still now the CPU basically are from ARM. So I think in the future, if the ARM technology, here there is a competition with AMD and Intel, and here ARM is basically a proprietary, meaning you have to pay for the use. And here the same thing, RISC-V, basically they created similar things where they make it open source, so that the chipset and everything can be lot cheaper in the whole world, basically. So for that one, there are companies, there are big companies like there are a number of companies that they have in the RISC-V. They're creating the hardwares like the Sci-Fi. There are Western Digital, there is Microchip, and some other companies. Okay, so the MIP is another. So those companies are right now coming up with the better performance CPUs and better the hardware consumption of the power is very low. So they are coming up. One of them basically who topped them all on the one you mentioned a while ago is in the in last RISC-V summit in the US.
Yeah.
Is they call it the Ventana. Ventana Technology is one of the company that they are right now creating a 128-bit CPUs core. Sorry, 128 core CPUs, and I will talk about a little bit more on that one with Ali. What is RISC-V CPUs that Ventana is? What is Ventana?
So Ventana new RISC-V CPU core is the centerpiece of the first compute chiplet solution with chiplets supplied by different companies. Ventana's Veyron platform solution also enables integration of flexible domain-specific accelerator for hardware and software code design. Ventana CPUs are based on the RISC-V ISA and offer a number of features and benefits, including low power consumption. Ventana CPUs are designed to be energy efficient, making them suitable for use in battery-powered devices. High performance. Ventana CPUs are optimized for high-speed performance, allowing them to handle complex tasks easily and quickly and efficiently. Customizability. Ventana CPUs can be customized to meet the specific needs of different applications, making them highly flexible and adaptable. And lastly, open source. The RISC-V ISA is an open source, which means that anyone can use and modify it. This makes it easier for developers to create custom solutions using the Ventana CPUs.
Okay, so what will be the conclusion of that?
So the conclusion will be that the Ventana RISC-V CPUs are powerful and efficient processors that are well suited for use in wide-range applications. They offer a number of benefits, including low power consumption, high performance, and customizability, making them a popular choice for developers looking to create cutting-edge solutions.
Yeah, so basically the what Ventana came up right now, basically, I fully understand. You see the government of the whole world, like, of course we are in the Philippines, we don't have maybe much about technology, but India government, they invest billions on the RISC-V development. The problem is, you understand, the government, they spend a lot of money, but on the wrong resources, wrong way sometimes. So Indian government, to cut the story short, Indian government come up with a plan, a brilliant plan, that they're going to have a RISC-V CPUs developed by the government, for the government, and for the country as well. So, but they invest billions there, but end of the day, their results was a disaster. So where is Ventana basically, or company like Ventana can be a very handy. It is a company where is already a custom resources are there, customizable CPU designs are there. So companies like the one India, if India, so that one of the things that I was thinking about in the past is or right now is, maybe we come up with what RISC-V did. They come up with a foundation, So where is a lot of members are becoming member. So you just have to donate like $250,000, for example, to become the member. And then you get all the resources, all the things open source. And one of the companies that I mentioned, Sci-Fi, they are basically one of the company, basically are the one, they are the leading RISC-V provider, meaning when the RISC-V was not doing very good, it is the Sci-Fi who really spend a lot of resources for so the credit really goes to them. But of course, Ventana here, the CEO of Ventana basically Indian as well. So if the government, any countries, they come up with a joint venture, like a open source, it's not only India, like for example. So it can be like Philippines, India, Dubai, UAE, Saudi Arabia. So there are like, okay, let's say 50 countries come together. Then they invest, okay, one country invest $5 billion. Then they come up with a consortium and they come up with something similar to open source or for the government. So it can distribute their money and their risk will be very, very reduced. Like whatever it is, the risk. So risk will be very reduced. So basically, that's basically what the government basically should be doing. So in that way, the Indian government, the money they lost, it will not be lost forever. So you see, the Apple, the Samsung, they're taking away all the money of different countries because of their high-tech gadgets. We are buying it with thousands of dollars, right? So, but what if a Philippine government produce a CPUs, Philippine government produce a hardware, which is they are partner with different countries, then they partner with a company like Ventana or Sci-Fi or somebody that is creating a very good CPUs, very good processors, very good design. You don't need to hire a lot of resources. All you have to do is just go brand, name it different names, like, okay, made in Philippines, India, like that. So that basically something that the government can do instead of wasting up their money. So basically that's the reason why we talk about this. So, and in again, there are current news, which is there is a summit happened just I think last month in San Jose, in the US, right? So where is there are a lot of companies who participated. I supposed to basically go there, but with our time and everything, I was not able to join there. But I'm planning to join the one in Taiwan in February if I have time, or maybe there is one in May. So let's talk about the current news on the RISC-V CPUs summit. Atif, we talk about that.
The current news are that last week we attended the RISC-V summit in San Jose. Traction in the RISC-V ecosystem is accelerating faster and faster. The embedded world has shipped tens billions of RISC-V cores collectively over the last few years. Qualcomm has silently shifted control and security cores that are not exposed to the user since 2020. S865 chip. This has enabled them to ship a lot of total of 650 million RISC-V cores. Andes and Codesip are each at over 2 billion RISC-V cores shipped. Western Digital ship over 1 billion RISC-V cores a year. And even Apple is converting some non-user facing functions to RISC-V.
Okay. So you can see there are tens of billions of RISC-V CPU cores are being deployed already. That means that is becoming something very, very handy and very, very popular in the whole world. And even the giant companies like Qualcomm, like Apple, like Western Digital. So those are the giant companies, big companies. They are basically moving some of their things that they used to pay to reduce their costing. So in the future, as one of the scientists that I see he talk about that someday the chips will cost you like a penny. So of course, if it is open source and it becomes cheaper and cheaper someday, and we can have more powerful things to be done with our artificial intelligence and something else, and with very, very low cost. Right now we are buying a laptop with $4,000 and mobile phone on $1,000 or more, $1,500, let's say iPhone. So those are not very, very cheap, right? So if we can come up with the technology very cheap, we create something very cheap. Of course, the mobile phone will be very cheap as well, and more people will be able to use the mobile phones. And anyway, so I will go for the next news, I will ask Alip to continue the next. The soft.
The soft underbelly of ARM is being attacked extremely quickly by RISC-V cores from C5, Codecit, Alibaba Imagination, Western Digital, Andes, Exmos, and MIPS. RISC-V will surpass ARM in the embedded and microcontroller space by 2024 or 2025. Further on in this report, we will also share some shocking details we learned about ARM's nuclear option with regard to forced bonding to exist in the licensees. The question on everyone's mind is when RISC-V will come to user-facing applications. The answer is that this may be closer than people expect. There are currently 4 companies working on RISC-V cores that compete with the biggest and fastest from Intel, AMD, ARM, Apple, and etc. These 4 companies are Ventana Microsystems, Tensor, Rivos, and Akina. Each of these companies have teams with impressive pedigrees, but that alone doesn't guarantee success. Cutting right to the chase, Ventana's Veyron VT1 per core performance is comparable to Neoverse V-series from ARM, V1 in Amazon Graviton, and V2 in NVIDIA Grace, but at higher clocks. Furthermore, it scales up to 128 cores within a 300-watt power budget. This is comparable to what AMD's Genoa can do. Ventana can also achieve twice the core counts of Amazon's Graviton 3, albeit with higher power. Another important distinction is that AMD Genoa and Graviton 3 are measured in silicon and available to customers. Ventana's performance figures are simulations with the actual test coming after tape out in Q1. About new product power introductions, we generally believe it's all talk until the silicon is in the lab. Suppose these first-party figures are missed by even 20%. Ventana will still smash Intel's current generation Ice Lake and even Intel's next generation Sapphire Rapids, which doesn't ship in high volume until mid-2023.
Okay, so basically, so we can see that that a lot of competitions are coming. This 2023, there will be lot competitions on the chipset market and design market. So there are a lot of microsystems, there are a lot of design companies are coming up, and they're coming up with different types of chips. And I believe that the chips will not be like a microcontroller anymore.
Yeah.
So I believe that the chipset will be going is different directions. So there might be companies that they are going to follow on the artificial intelligence measured chipset. They're going to create on different directions. That's why the market is opening up. The market is widening up. We talk about the ChatGPT and the OpenAI, how OpenAI can do conversations and do lot of works for human work. So it can take out a lot of human works, daily boring jobs, basically, to be honest, chatting all day, answering the questions and all those simple things. So we all know that the ChatGPT, they have 175 billion data conversion. So they have 175 billion data set. So to be talked about. So it's all about data set for the artificial intelligence. So if we put up a wrong data set, it will be wrong. If we put up the right informations, it will be right. So that's why there are things. So to create this, the reason I mentioned this one, to create this 175 billion instruction set, the data set, it consumes a lot of CPU powers. Okay, lot of not really CPU powers, GPU powers. Okay, so there are CPU intensive jobs, there are GPU intensive jobs. So these two we have to be careful. So we match those things. So for that GPT, they spend billions maybe for their 175 billion the data set. And there are Megatron, and there are other data set company. They are putting up like 500 billion, 330 billion. So there is one company that I read last night is that they come up with only 70 billion data set, but it's like this. Their data set is less, but their accuracy is more higher. So it's like this, they were saying. So meaning when the AI maybe was created in the beginning, they created the data set, maybe there was the data set was not created properly, so that they have a lot of data, but the accuracy was not minimized. So of course there will be new companies coming up with artificial intelligence. They will think about how to reduce the data set. So the data set meaning that many computing power is required for an answer. So if the data set is reduced, the computing power will be reduced, the answer will be faster. So basically that's what they're fighting right now on the AI horizon. So we heard about what Microsoft did. Microsoft already investing $10 billion on the OpenAI and taking away and putting up in Office, in next Windows 12. They're putting up that OpenAI. That's why DeepMind is coming up with other side. On the other side, they're coming up with their technologies as well. So to do those, we need a lot of computing power. So to make that, we need a more efficient hardware. We need a more hardware that will be efficient or more performance based. So a lot of companies. That's why a lot of companies are fighting, because the cloud is everywhere. In the Philippines, we see there are $1 billion data center is coming up this 2023. One of these days we will come and we'll have a live videos there. We'll apply to go there to see how the data center is being set up. So on the opening, maybe I will go also there. Anyway, so those are the reason why we need this hardware to be more efficient, less power hungry. So on that one, basically there are other things on the hardware of RISC-V that we talk about. Today we'll talk about again what is the Chisel.
So the Chisel is a hardware design language, or HDL, that is used to design and implement digital circuits such as microprocessors, memory controllers, and other complex systems. It is based on Scala programming language and was developed by the Computer Science Division at the University of California, Berkeley. HDLs are used to describe the behavior and design of digital circuits at a high level of abstraction. And Chisel is a popular choice for hardware design due to its simplicity and flexibility. Chisel allows designers to specify the behavior and structure of digital circuit using a high-level hardware description language, and then automatically generates the lower-level hardware description language HDL code, such as VHDL or Verilog, that is required to implement the design in an actual hardware device. In simple terms, Chisel is a tool that allows designers to create digital circuits by writing code rather than using traditional methods such as schematic capture or manual layout. This can make the design more efficient and allows more designers to more easily verify and debug their designs.
Yeah, so basically that's basically is something that is like you are doing a design which is basically, in the past example, you were doing design on Adobe something or AutoCAD, or if it is doing something for architecture, AutoCAD, doing for the hardware chips, there are software that is being used for designing the hardware, the microcontroller, microprocessors, and all those things. But what Chisel does is it creates like a code.
Yeah.
So it's not basically, it's like in the past, right? We have the GIF file, right? Or PNG file, right? And then right now we have SVG file. SVG is basically a bunch of code. It's not basically it's not basically a image.
Yeah.
Basically, it's a bunch of code in the background. So those bunch of code generates the image, right? So it's basically similar to that one. That instead of you're creating a manually, you're creating a drawing board in like a drawing board. You put your data. Instead of that one, you create a programming language. You put a programming to create the circuit board basically for it. Basically, that's basically all about the Chisel. So basically, the reason why we talk about Ventana, the reason why Ventana was really able to do things very fast is basically because of Sci-Fi. Because Sci-Fi created a lot of softwares and put it open source. That's the reason why today whoever is joining the RISC-V community, they basically owes to Sci-Fi. Because Sci-Fi needed to develop their drivers, because RISC-V is different than architecture and modules than other architectures. So they need to have the compatibility for the hardware from the software. For example, you need to run the RISC-V to a device, a hardware. So they need to write a code for the driver, for the driver. Okay, they call it driver for any kind of hardware, like GPUs. You need a driver for GPUs in order for your software to understand the GPUs, how it will function. So of course, when the RISC-V comes up, they don't have a software, they don't have the driver, they don't have all those code. So it's the Sci-Fi who basically define all those codes for RISC-V right now. Right now, RISC-V become very big because of
So-
what Sci5 did basically. And Sci5 invested a lot of money on the RISC-V in order for these things to happen and see the lights of the day of the RISC-V. Basically, RISC-V also designed, not in design, basically here in the same place that you mentioned a while ago, the University of the California. Basically, that's where the RISC-V also was designed. So they're the one who created this Chisel in order for them to hardware and software can work together. So there are right now there are a lot of companies who are, again I told you in the past, there are a lot of companies right now member of RISC-V, but there are few who are very big or top on the list. So there are names. Let's just talk about the names of those companies.
So there are Western Digital, Microchip, Esperanto Technologies, Andes Technology, Codasip, Rambus, NXP Semiconductors, Marvell, FlexLogix, TNCL, Ultrasoft, and that's all.
Yeah, there's basically a lot of
There's-
them.
yeah,
Lot of
there's
them.
more.
So there are more of them are coming. There are new companies that basically what again I mentioned a while ago that the RISC-V is and the x86, which is the Intel and AMD are based on, are basically totally a different type of hardware, so instruction sets. So one is based on RISC architecture, one is based on CISC architecture. So in the future, the way I look at it is the RISC based architecture on the mobile, on the other devices, or the whole world is going to be taking over the CISC because of. So I believe Intel and AMD, they need to move fast, or they need to change the way their architecture designs of that. So what is the future prediction, do you think, for our RISC-V CPUs?
So as you said, Mr. Sajid Khan, that the RISC-V will gain traction in the market either with the systems like IoT sectors or in AI and most other things.
Okay. So basically that's basically. So I believe the RISC-V is going to continue gain their traction on the market, and that's basically bad news for AMD and Intel at the same time. But what I see on the Intel, basically they oversee all those issues. So that's why Intel CEO last time they work with the US government. They have this $52 billion the chip the act by the US government, and they're giving the subsidy to these companies. So what Intel did is, instead of focusing on their hardware design, or Intel they're more focusing on the fab, because all these companies, regardless of RISC-V, regardless of Intel as other companies, that they will require a manufacturing plant in order to produce these chips. So what Intel did is, they knows that they're losing on the market, on the chip market, or on the desktop market, on the other market. They are competing with the what do you call these Taiwan companies,
TSMC.
that TSMC. They're competing right now with the TSMC and Samsung in Korea, and putting up a lot of fabrication companies to have this chip to be manufactured. So I think Intel is having a bright move that they're taking, putting up the factory where is even their competitor will produce chips, and they're going to make money out of that one. So I think that's a brilliant idea, and I think at the end of the day they will have their good days. So 2022 was not very good for Intel, because they are spending a lot of money, billions of dollars, to set up in Europe, in US, and because of Intel's all this effort of this Intel CEO, today US is seeing a lot of chipset companies are putting up their billions of dollars investments, and they're having, we talked in the past about this China and as it was
Chip war.
the chip war, and that chip war is being moved right now to the US side, because even TSMC, like Taiwan, they are moving their chipset. They put up Arizona chips is coming up there. They're opening up their factory very soon. So anyway, so we talk about this RISC-V basically are the one who will be taking the future away from other companies of the CPU design and hardware design as well, because of their nature of open source system.
Okay. that concludes our today's episodes all about RISC-V CPUs and companies. Once again, thank you to our CEO, Mr. Sajid Khan, and thank you viewers for watching. Have a nice day.
Hello, techies! Please don't forget to like, share, subscribe, and hit that notification bell for our future videos.
And you have any further questions, please comment down below.